to the Fan State Classroom. I am Garrett Tobert, and today we will be going over equivalent resistances. So what equivalent resistances is pretty much you will be given a circuit as such, and they want to know what is the resistance from terminals A and B. So pretty much what we're going to do is we are going to combine multiple resistors in two ways. You have resistors that are in series, where they only share one node, so they look like this. There is no connection in between those two. And then you have resistors in parallel, where they share two nodes. And we will do two problems, so you'll get more in-depth knowledge about them. So given this equation, with this circuit, the first thing that you want to do is you want to go from the outside and go inside and work your way more towards both of those terminals. So the first thing that I would look at is these two resistors. So as you can see, these two resistors start right here and right here, but there's nothing in between them. So these two would be in series. And as you see from this diagram right here, when two resistors are in series, you add them. So I'm going to redraw these circuits. So as you can see, when you sum up 2K and 2K, you get 4K. And so now we are still working from the outside in. So you have these two resistors are going to be in parallel. Why they're in parallel? Because this resistor starts at this node and ends at this node, if you follow the trail. And the same with this resistor. It starts at this node and it starts at this node. So we can combine these two. And with our formula, you would do 4K times 4K over 4K plus 4K. 4 times 4 is 16. 4 plus 4 is 8. 16 over 8 will give us 2. And so that would equal to 2K. Now, a quick tip is that if you have two resistors that are in parallel and they have the same resistor value, just slice that value in half, and that will give you your equivalent resistance. So I'm going to redraw it. So with this next step is similar to this one, where you both have 2K and 2K. It's the same step with these because there is no connection in between those two resistors. So redrawing. Okay, so again, just like in this example, the 4K and the 12K resistor are in parallel because the 4K starts at this node and it ends as right here, as well as the 12K resistor. So now you would do the equation, which is 12K times 4K over 12K plus 4K. And now 12 times 4 is 48. Over 16, that's equal to 3K. So redrawing the circuits. In our final step of this circuit, from terminals A to B, both the 9K and the 3K resistor are in series because there is no point connecting them. So you can just add those. So the equivalent resistance from terminals A to B is equal to 12K ohms. Okay, we're back again with a little bit more in-depth circuit problem. The way that it's oriented and the way that it is designed is the reason why I chose this problem. Because if we look back to our equivalent resistance rules, essentially, when when two resistors only share one node, they're in series. Rather, if they share the same two nodes, then they are in parallel. So again, we are trying to find the equivalent resistance from terminals A to B. And so we're going to start all the way to the right. So I would suggest doing 6K and 12K first. Now the reason is because once you get these two, this allows you to critically think about which way you want to put that next resistor. So I'll show you what I'm talking about. So as you can see, the 6K starts right here at this node. We'll call that node A, and then it ends at this node B. And if you look at it, this 12K starts at this node A as well, but this 12K ends at this node. We can call it, well, it's actually node B as well, because if you look at it, there is no circuit element on this line. It's just a line. So in that case, that means that they both are the exact same node. So essentially, both 6K and 12K do share the same two nodes. And according to our rules, when they share the same two nodes, they are parallel. So with that equation, we can do 12K times 6K over 12K plus 6K. This is equal to 72 over 12 plus 6 is 18. 72 divided by 18 is 4. 4K. So I'm going to redraw that. Now, the important thing, like I stated earlier, is where are we going to draw this 4K resistor? So, think about it. This node is the exact same as this node. So if you want to think about it, you're going to grab this node and you're literally just going to stretch it over here. That's what I'm about to do. So that means that this 2K and this 4K are going to be in series essentially. So here is the 2K, this is 2K, and this is the 4K. The 12K is up here, and we have the original 4K down here. And we can just drag this alongside. Now just to show you what I did again, the 6K starts right here and it ends at this node, and this 12K starts at this A node and ends at this node. But now this node and this node are the same exact node. Why? Because there is no element, there is no resistor on this line. So you can just bring this and shift it around essentially to that node. So once we did, so these two are in fact parallel. So we did the equation and came up with 4K. And now that's where it makes this entire circuit easy. Because the 2K and the 4K are in what series? Why? Because there is literally just one node that separates the two. So 2K plus 4K is equal to 6K. I'm going to redraw the circuit now. Keeping everything in place so we can identify which resistors are in parallel and which resistors are in series. Here's our 4K, 2 plus 4 is 6K. Drop that down. Now which one do you think that we're going to tackle next? The 6 and the 4 or the 12 and the 6? Now remember, we are working from the outside in. So it's really not, it really doesn't make sense for us to do the 6 and the 4K since we're trying to find the equivalent resistance across terminals A and B. So it's best for us to do the 6 and the 12K. Now, if you look at the 12K, it starts right here at this node A and ends at this node B. And the same is going on for this 6K. So these two are in fact parallel. So we can do the operation. Say 12 times 6 over 12 plus 6 is the same as previously. That will give us 4K. So I'm going to redraw the circuit. And again, you can critically think about where to place this circuit, but we can just replace the 6K in this example. Okay. So now the 4K starts at this node and ends at this node. And so does this 4K, which means that both this resistor and this resistor are in what? Parallel. So what's the rule for parallel? Well, what's my little trick that I told you guys? If two resistors are in parallel and they have the exact same resistance value, then you can just slice that value in half, and that's your equivalent resistance for those two resistors. So since this is our final step, we can say that the equivalent resistance across terminals A and B is equal to 2K ohms. So now remember, from 6K to 12K, because we're starting from the right end, these two are in parallel. That gave us this, which gave us the 4. The 2 and the 4 are now in series. Bring those together, we get 6K. The 6K and the 12K are in parallel, so now that equals to 4K, and the 4K and this 4K is in parallel, and that gives us 2K ohms.